Hello everybody, and thank you for using Danomics. In this video, I'm going to go over how we can make a series of grids from our petrophysical interpretation. Let's get started. So instead of building this flow from scratch, we're actually going to use a template that's available to us within the software. If you come down here to where it says example flows in your files area and expand that out, and you click on the flow called 2A petrophysics maps.flow, you can see it gives us a starter flow that's available to us. Now this flow is in a template and it's read-only, so what we can do is say File and then make a copy, and I'm going to call this CPI maps.flow and hit OK. I'm now going to close the example. I'm going to move this flow into my Welcome Project folder. I'm just doing this to keep myself organized. You can run it from wherever. So within this CPI maps, it now tells me that I need to set some values here. So I'm going to start with my log input block, and I'm going to bring in, let's say, data from this cleaned up log database. I'm then going to come in here to my CPI log calc block, and we can see it's got a number of properties that are pre-selected for us. What I will need to do is then select my petrophysics file. So I'm going to select my CPI where I've done my interpretation, my tops, headers, and my keywell dataset. And in this case, I'm actually using a spatial grid, so I'm going to bring that in by just hitting the update button. Okay, so that brings in the properties into my flow. I'm now going to look at the points to grid block. And here we see that it's grouping by property and by zone, which is how we would like to do the map. And then we have our columns lat, long, and then the value column and our points file. And then we have a grid output. And I'm going to call this Welcome Project Grids. Okay, so what this will do, just to rehash, is it'll bring in our logs. It'll then calculate these properties, returning points on a zone by zone basis. It'll then convert those points to a grid. And then finally, it'll output the grid. To run this, I just hit the play button. And what it'll do is it'll bring up the jobs menu where it'll go through the 3 steps of initializing, running, and finished. Okay, now we see that our flow is finished running. We can inspect the results of the flow in a couple of different ways. So first of all, it's always useful to click on the report and see if there were any errors or messages that we need to look at. So if we click on that, it tells us what's been ran, the properties that have been calculated, and then we can see some information about the gridding, and we can see how long it took the flow to run. Okay, there are no errors there. We can click on the outputs here. So we have these welcome project grids.grid file now. So if I click on this, it brings up a preview of the grid. And you'll notice that we've not just made one grid here. We've made approximately 40 grids for about a dozen zones. So, let's say I want to look at my hydrocarbon pore volume summary for the Niobrara Formation. Well, that's available to me. So now that we've made approximately 500 grids. Now, much like other flows, this is a flow that is very reusable. Let's say I went in and I made some modifications to my petrophysics interpretation, and I wanted to see the effect that that has. Well, I go to my petrophysics, let's say I make a change here on my well. I want to see what happens if I change the mineral model. So let's say I wanted to use pyrite across all my zones, and I wanted to calculate kerogen across all my zones. Well, I could do that, save this, and then I could come in here and simply rerun this flow, or I could give this a a V2 here, or whatever iteration name I want, hit run, it'll run that flow, and it'll generate, once again, all of those grids, so I can really see how this has changed my results throughout. And it allows me to go in and be able to do comparisons of one versus another. The other use case for flows here is that we could make a copy of this flow and we could use it on a different petrophysical project. And all we would do in that case is we'd come in, and in here, instead of selecting the CPI for our welcome project, we would select the appropriate files here and in our log input. So this quickly becomes a way where you can generate a consistent set of maps across all of your petrophysical projects without having to tediously do this property by property and zone by zone like you do in other conventional softwares. You could also do this for your petrophysical curves, where if you always wanted to write out a certain suite of curves to your database, well, you could do this. Generate that database, and then that database is available to download whenever you need it. So flows are a very powerful tool that can give you a number of different ways to run a repetitive process, and you can update this process as needed. So if you wanted to add grid smoothing or outlier removal to this, you could simply come in here, add grid smoothing in this case, and rerun your flow, and then you would get out a lightly smoothed version of all your grids in this example. All right, I hope this has been useful to you. If you have questions about how to run this type of flow to generate grids from your petrophysical interpretation, or about any other type of flows, please feel free to reach out to us at support@danomics.com. Thank you.